Howdy and welcome back. So we will continue today's lesson by getting into some of the motivation for class templates. We're going to start by kind of looking at some different variations of the standard library vector for different types of collections of elements. This slide, the next, and the subsequent were taken from a Bjarne-Stroustrup's programming principles and practice using C++ book. So this is what he kind of laid out to help illustrate this. If you're looking at, say, a vector of double, there's a couple of data members that you need to store, right? You need to know the size, you need to know the capacity, which here's space, and then you also need a pointer to the element on the free store, or excuse me, the array on the free store that is storing your collection of elements of some type. In the case of a vector of doubles, that is going to be a pointer to a double because the base element in that array to which the pointer will point is going to be a double object. If we go ahead and continue to kind of explore this, we can see, where double's presenting. If we're subscripting into our vector, we're going to return a reference to a double. And if we're constructing a new vector of double, we're going to go ahead and initialize Elm, the data member Elm, with the address of a newly allocated free store array. Now let's look at how that varies from, say, a standard library vector of characters. If we look here, the only thing that's really changed is that we're no longer maintaining an array of doubles, but we're maintaining an array of characters. So we essentially just update both the data members and the relevant behaviors to reflect this change. And it's literally just changing out double and replacing it with character in 3 spots. So you start looking at this and you realize, okay, well, the kind of behavior here is generic. If we're pushing back, say, an element onto our vector of characters versus one of doubles or ints, that operation is going to be more or less the same, irrespective of the type of element we're pushing. More so, if we look at kind of any of this, the implementations, it doesn't really change depending on the type of object stored. So is there a way that we could create a vector template for all types T? That is, could we somehow design our class such that we could instantiate it for the various types of objects that we would like to store in this vector? And the answer is yes. And we'll see here that class templates allow us to do that by leaving open the types for some of our data members, such as Elm, as well as for some of the parameters, as well as local variables presenting within our function members. So we'll go ahead and get into how we can introduce class templates in C++ here in the next video before moving into some of the implications of this with respect to the compilation process.